This quote from TikTok CEO Shou Chu provides a simplified but insightful explanation of how TikTok's recommendation algorithm, the engine behind the For You page, FYP, works. Let's expand, explain, and expound on its key components. 1. The recommendation algorithm is really just math. Explanation. At its core, the algorithm isn't making subjective judgments about what's good or bad content in a human sense. Instead, it's using mathematical formulas and statistical models. These models process vast amounts of data to calculate probabilities and make predictions about what content a user is most likely to engage with. Expound. This demystifies the idea that there's some secret source or human curation controlling everything. It's driven by data patterns. The math refers to complex calculations involving vectors, representing users and content in a multidimensional space, similarity scores, and predictive modeling. 2. If you like videos 1, 2, 3, and 4, and I like videos 1, 2, 3, and 5, and he likes videos 1, 2, 3, and 6, now what's going to happen is because we like 1, 2, 3 at the same time, he's going to be shown for 5, 6. Explanation. This illustrates a core concept in recommendation systems called collaborative filtering. The system identifies users with similar tastes. You both liked videos 1, 2, and 3. Because of this shared interest, it predicts that you might also like other videos that people similar to you have enjoyed. Video 5 and 6 in this example. Expound. It's about finding neighbors or taste clusters. If many users who like videos A, B, and C also like video D, then a new user who likes A, B, and C is likely to be shown video D. This also works for content. If videos X, Y, and Z are often liked by the same users, they are considered similar, and someone liking X might then be shown Y and Z. 3. You can think about this repeated at scale in real time across more than 1 billion people. Its math AI and machine learning has allowed this to be done at a very, very big scale. Explanation. The simple example above is magnified incredibly. The math, AI, and machine learning are what enable TikTok to perform these similarity calculations and predictions for over 1 billion users and an even larger number of videos, all happening constantly and updating in real time as new interactions occur. Expound. Scale. The sheer volume of data, users, videos, interactions per second, requires highly efficient algorithms and powerful computing infrastructure. Real-time. The FYP isn't static. It's constantly learning and adapting based on your immediate actions and the actions of others. AI and machine learning. These are the enabling technologies. ML models are trained on the data to make these predictions without humans explicitly programming rules for every possible interest. 4. What we have seen is that it learns the interest signals that people exhibit very quickly and shows you content that's really relevant for you in a very quick way. Explanation. The algorithm is designed to be highly responsive. It doesn't need a long history to start figuring out what you like. A few interactions can begin to shape your FYP. Expound. This is why a new user's FYP can change rapidly as they start interacting with content. The system is constantly updating its understanding of your preferences based on fresh signals. This rapid learning also contributes to the discoverability of new trends and creators. 5. We don't actually ask you 20 questions on whether you like a piece of content and you know what are your interests. We don't do that. We built that experience organically. You are voting with your thumbs by watching a video, by swiping it, by liking it, by sharing it. You are exhibiting interest signals. Explanation. Unlike some platforms that require explicit preference setting during onboarding, e.g. select your interests, TikTok primarily relies on implicit feedback. Your actions directly signal your preferences. Expound. The key interest signals mentioned are watching a video, especially to completion or re-watching, strong positive signal. Swiping it, quickly away, strong negative signal. Liking it, positive signal. Sharing it, strong positive signal. Commenting, positive signal. Following an account, strong positive signal related to that creator's content. Content you create, also an indicator of your interests, sounds, effects, hashtags you interact with. These also contribute to your interest profile. 6. And what it does mathematically is it takes those signals, put it in the formula, and then matches it through pattern recognition. Explanation. Each interest signal, like share watch time, is weighted and fed into the mathematical model. The model then uses pattern recognition to match your evolving interest profile with videos that share characteristics with content you've positively interacted with, or that users similar to you have liked. Expound. Pattern recognition is a key aspect of machine learning. The algorithm identifies complex patterns in the data that correlate with engagement. For example, it might learn that users who watch long cooking videos, and also like videos with calming music, are likely to engage with ASMR cooking content. 7. You've got to have a message that resonates with people, and if it does, then it will automatically just have the virality itself. That's the beauty of user-generated content. Explanation. While the algorithm facilitates discovery, the ultimate driver of virality is the content itself. If a video resonates with a broad audience or a highly engaged niche, people's organic interactions, likes, shares, comments, watch time, will signal to the algorithm that it's valuable, leading to wider distribution. Expound. This highlights the democratizing potential of TikTok. The algorithm doesn't inherently favor big creators, though established audiences help. If user-generated content, UGC, is compelling and genuinely connects with people, it has a chance to go viral based on its own merit, as amplified by the mathematical signals those interactions create. The beauty is that authentic engagement is rewarded by increased visibility. In essence, Shou Chu is describing a highly sophisticated, data-driven recommendation system that uses collaborative filtering and other machine learning techniques to learn user preferences implicitly from their real-time interactions. This system operates at a massive scale to quickly match users with content they are likely to find relevant and engaging, fostering an environment where content that resonates organically can achieve virality.